If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everyone, welcome back to Anantha Lakshmi Academy. Today we are going to cover the concept that is needed for us to solve the problems of exercise 1.3 of real numbers chapter. Alright, so the concept that is needed for us to solve the next exercise is nothing but the rational numbers and their decimal expansion. Alright, so even before this video, I have already uploaded two videos. One is with exercise 1.1 and introduction, and the other is with 1.2 exercise. So please go through them even before you go through this to have a better understanding, because all the introductory part and the definitions were given in those videos. So when we spoke about rational numbers, we addressed two things. One is terminating decimals and the other is non-terminating and repeating. Okay, let us consider the example of 0.375. Okay, 0.375, 0.375. If I am to write it in the form of a fraction, I will write it as 375, and in the denominator 1, how many digits are there after the decimal point? Those many zeros. There are 3 digits and this thing. Alright, so here now this one 375 by 10 cube. Okay, let us get to the concept of 375. Let us find the prime factorization of this. 3 1s are 3 2s are 3 5s are 5 2s are 5 5s are 5 and 5. This can be expressed as 3 into 5 cube, and this can be expressed as 2 into 5 whole cube, which in turn returns 3 into 5 cube by 2 cube into 5 cube. 5 cube gets cancelled, 3 and 8. Alright, now let us understand the theorem which is based on this example. The first theorem states that let x be a fraction or a rational number of the form p by q, if you assume that x is a fraction which is terminated after a decimal expansion. So what is a rational number which is terminating after a decimal expansion? First variety of rational number is which is terminating after a decimal expansion, right? That is nothing but this example. So let x be a rational number which terminates after a decimal expansion. Then it can be expressed in the form of p by q, which is 3 by 8, where p comma q are co-prime. What is co-prime? Two numbers are said to be co-prime when they have only one as their common factor. Okay, now for 3 and 8 only one is the common factor. Alright, that is satisfied, and q can be expressed as 2 power n multiplied with 5 power m, where n comma m are positive integers. Okay, if you have seen the denominator, it was expressed in the terms of 2 power 3 and 5 power 3, 2 cube and 5 cube, right? That is what they are trying to say. When you consider a rational number which is of the form p by q and that is a terminating decimal, where p and q are co-prime, they have only one as their common factor, then the denominator q can be expressed as 2 power n multiplied with 5 power m, which is the same as 2 cube into 5 cube, where n and m are positive integers. Okay, this is first concept, first theorem. And the second theorem is nothing but the vice versa of this, where they say that for a fraction whose denominator can be expressed as 2 power n multiplied with 5 power m, then the decimal terminates for that particular fraction. I am trying to explain it in the simple words. The second one is nothing but the vice versa, wherein they say that if x is a fraction like p by q, where q can be expressed in the form of 2 power n multiplied with 5 power m, where n and m are positive integers, then x is a rational number. X is a rational number whose decimal terminates. Okay? Terminates. It is all about the termination of the decimal and the denominator being written in the form of 2 power n and 5 power m. In the first thing, they are saying that a fraction or a rational number can be terminated only when you can write q in the form of 2 power n and 5 power m, and p and q are co-prime. That is first theorem. Then we have the second theorem, which says p by q, which can be written in the form of 2 power n 5 power m, then and p and q are co-prime, then the rational number or the decimal terminates. Alright, this is the first theorem, which is based on the first type of rational number, which are terminating. Okay, then we need to look at the non-terminating decimals. Alright, let's look at the non-terminating decimals. So consider the example of 1 by 7. You know what is 1 by 7? It is given in the textbook as 0.1428, 1428571, and it is going on. So when we are discussing about the rational number, we thought one of the kind was non-terminating and non-repeating. This is of that kind. So far we have learnt two theorems for the terminating decimal. First thing is, when it terminates, the denominator has to be of this form. The second thing is, when the denominator is of this form, the decimal expansion terminates. The third concept is, when q is not in the form of 2 power n and 5 power m, then the decimal expansion is non-terminating. Alright. So far we have defined further terminating examples itself, and vice versa, right? The denominator has to be in 2 power n 5 power m for terminating decimal. If the denominator is in 2 power n 5 power m, then the decimal expansion terminates. That's what we have discussed. Now the third thing, when q is not in the form of 2 power n 5 power m, then the decimal expansion is non-terminating. Are the three important theorems which needs to be understood well to solve the problems of exercise 1.3. Okay, first thing is, let x be a rational number which is of the form b by q, where p and q are co-primes. Then q can be expressed as 2 power n 5 power m, where n and m are positive integers. That is the first thing which we have learned. Next thing is, if x is equal to p by q, denominator can be expressed in the form of 2 power n 5 power m, then the decimal is terminating. Decimal expansion is terminating. Then the last thing, if you consider x is equal to p by q, the rational number where q cannot be expressed in the form of 2 power n 5 power m. 7 can never be expressed in the form of 2 power n 5 power m, right? For such kind of things, then the decimal expansion is non-terminating. Alright, this is about the concept of rational numbers and their decimal expansion. So now we are ready with the concept. We have understood the concept. Let's jump into the exercise problems. So far, if you have understood the concept, please make sure you are liking the video, because by the time you reach the end of the video, you might forget to like my video. Alright, so let's jump into the exercise part. So far in the third theorem, I have written it as non-repeating, but it is, repeating. It is a recurring decimal. When the the denominator is not in the form of 2 power n and 5 power m, then the fraction is decimal expansion is non-terminating and repeating. Alright, so please make a correction to that. Next we are to solve the exercise 1.3 problem number 1, which is 3 by 8. So they are asking us to write these rational numbers in the form of their decimal expansions and figure out whether it terminates or not. Okay, how could we write 3 by 8? 3 by 8 can be written as 3 by 2 cube. By this, can we tell whether this is terminating or not? Here, the denominator can be expressed as 2 power n 5 power m, where 2 power n 5 power m, right? What happens if I substitute 5 power 0? It is 1. So whenever you could substitute this as 2 power n and 5 power m, either it should be divisible by both 2 and 3, or it should be divisible by 5 as well. So let us consider here the denominator can be expressed as 2 power n and 5 power m. In order to get that, let us multiply it with, write this statement, multiply with 5 cube, because we wanted the decimal expansion, right? 3 into 5 cube divided by 2 cube into 5 cube. Alright, what happens? 3 into 5 cube is 125 into 3. 3 5s are 125 into 3 is 3 5s are 15, 3 2s are 6, 7, 3 1s are 3. 375 divided by 2 into 5 is 10 cube, which is nothing but 370 by 1000. And if I express it in the form of decimal expansion, this becomes 0.375. When you have 3 zeros, there should be 3 digits after the decimal point. Hence, this is 0.375. What is this? Is this a terminating decimal or not? Yes. So, this is the decimal expansion of 3 by 8 and this is a terminating decimal. Alright. So, this I am solving one of such kind. There are rest of them. Please do by yourself, and if you are not able to get any of those, please ping in the comment section saying, can you please solve this for us? I could not get the answer, so that I will be solving this. Alright, let's jump into the second problem. Here is the problem number 2, in which they are asking to figure out, without performing the actual division, try figuring out whether this is a terminating decimal or non-terminating and repeating decimal. Okay, so we have learned the concept, right, within which we figured out that if x is equal to p by q, where q can be expressed in the form of 2 power n 5 power m, then the decimal expansion terminates, isn't it? If q is not equal to 2 power n 5 power m, then this is non-terminating and repeating. So in order to solve this, what do we need to figure out is whether this denominator, if this can be expressed in the form of 2 power n and 5 power m, that is what we need to figure out. So let us try expanding 3125 first in the form of its prime factors. So 3, 8, 9, okay, let me do it with 5. 5 6 are 30, 5 2s are 10, 5 5s are 5 1s are 5, 5 2s are 10, and 5 5s are 25, 5 2s 10, 5 5s and 5 and 5. Okay, now so this is equal to 13 by 5 power, how many? 1 2 3 4 5. So here are we able to express this in the form of 2 power n 5 power m? Yes, we are able to express it in the form of 5 power m. So in 2 power n 5 power m, if we are not able to express it either in the form of 2 power n multiplied with 5 power m, then this is non-terminating. But here we are able to express it in the form of 5 power m, right? So this becomes a terminating decimal. Why? Because we are able to express it in the form of 2 power n and 5 power m, where n is 0 and 5 power m is nothing but 5 power 5. Alright, that is about problem number 2. Let's jump into next problem. And rest of the things are also quite familiar. You can do it in the same form. Consider the problem number, bit number 2, 11 by 12, wherein 12 can be expressed as 2 into 6, which is 2 into 2 into 3. Here if you consider, this is expressed in the form of 2 square and 3, but not in the form of 2 power n or 5 power m. If it is expressed only in terms of 2 power n, that is also fine. If it is expressed in terms of only 5 power m, that is also fine, because the other power we are assuming it as 0. But this is expressed in terms of other prime factor, which is 3. So this is not of the form 2 power n. Q is not in the form of 2 power n 5 power m, isn't it? Hence this is what? If it is not in that form, then this is non-terminating and repeating. Alright, so this is about problem number 2. You have a few more bits to be solved. You better solve them by yourself. If you are not getting, please ping in the comment section asking me to solve so and so problem. Okay, let's jump into the third problem. They are asking us to solve this using theorem 1.4, which states that if x is equal to p by q is something which can be expressed in the form of 2 power n and 5 power m, then the decimal expansion terminates. That is what theorem 1.4 is. They are asking us to write the decimal expansions of these using that. So let us try figuring out if this can be written in the form of q can be written in the form of 2 power n 5 power m or not. So that way it becomes 13 by 25, 13 by 5 into 5. In order to make sure the decimal terminates, we have to have it in the form of 2 power n 5 power m. So this is 5 square, right? So let me multiply the denominator and numerator with 2 square. That way it becomes 13 into 4 by 10 square. 13 4s are 52 by 100. When I consider it to the point, it becomes 0.52. As we have 2 zeros in the denominator, we need to have a decimal. After decimal, we need to have 2 points. So this is 0.52. So if you see this is 1 2 0 1 2 0 1 and so on, it is going on. So if you observe this, the pattern is non-repeating and also non-terminating, isn't it? Even if I try to write it in the form of a fraction, I don't know what is coming in this part. Alright, so this is nothing but, I'm giving a hint for these problems. This is non-terminating and the pattern is also non-repeating. So for the second problem here, if you observe 1 2 0 1 2 0 1, the pattern is not repeating and this is also not terminating. So that is what we have written here. So for this 43.12222, so this is like 43.12121212. All right. If you observe, this is repeating and non-terminating. What is this? Repeating and non-terminating. Non-terminating and repeating could be expressed as P by Q, where 4312 by 2 zeros. Okay, this can be expressed in the form of 4312 by 2 power n 5 power m whole square. All right. For the first problem, I have solved it as a whole. For the next two problems, I gave you a hint on how to solve this because I thought these are little complex. All right. So this is about exercise 1.3. Congratulations, we are done with exercise 1.3 as well. So if you are able to understand the concept and solve the problems on your own for whatever the problems which I have not explained, please share this video with your friends, classmates, or any relatives who are in need of these classes, like who are studying in 10th class. All right, if you feel the content is worth enough, please make sure to subscribe to Anantha Lakshmi Academy. Thank you for watching.